सो एक्चुअली आज स्टार्ट करते हैं अपना POTD. So I was recording the series of POTD, but due to my exams I stopped it. So now again I am continuing it. So I have tried the POTD and I want to also give you the solution and approach for the same. So this is the question. Question says taking maximum energy from the mastic dungeon. Now I expect that you would have seen the question and then come here. So you would have thoroughly studied the question and also got what the question want to say. So I don't think I want to explain the question. I don't need to explain the question, but I can explain so that some of them, those who didn't get the question, can get the question, and those who have got the idea about the question, they can skip this part. So you are given a magic dungeon and there are n magicians and standing in a line. And what you can do, you can start from any magician and take that energy. For example, you can start with this two and take this two. Now, but once you started, you would what you have to do? You have to take continuous energies in the sequence I plus k, I plus 2k, I plus 3k in this sequence. Okay, so this is the way in which we have to take the energies, and now we have to find that what is the maximum possible energy count that we can get. So see, I don't know that you have a knowledge of DP or not, but this is a classical problem of a DP. If you think I don't think that there is a need to know DP for this question. You can just use approach. So what is approach? See, at position I, what is the choice that you have? First of all, you can start from this. You can start from this I. Or second thing is that if you want to continue previous sequence, then I minus k sequence you can add in this sequence. What I want to say, see, there is 1 2 3, these are the indexes. Now at each index I, at each index I, what you can do, you have two choices. Either you can start the sequence from I, and the second choice that you have is that continue the previous sequence, which would have been started or continued till I minus k, because you know that we are increasing in the sequences of length k. So in I minus k there would have been a continuous sequence, and you can use that sequence. Now since you want to find the minimum, so sorry, maximum energy, so we will take maximum at each step, and in the end we will be able to get that value. So I think that you would have got the approach. If you don't get the approach, you can comment down and I will explain to you. And you can also see some other solutions which will be working. But I think I am giving the videos so that you can get more idea about how it is continuing. At each index you have two choices. Either you can start a sequence from this one and continue from this 2 I plus k I plus, or you can from backward I minus k I minus 2k, you can continue that sequence by adding this current in that previous sequence. So first of all, in we take an variable n, which is to store the size of the energy size. Now we make a we make a vector and a DP. Now some of you would who have knowledge about DP would be understanding what it is a DP. It is somewhat like DP. But those who don't have idea, you don't need to understand DP to get this question. You can also see this question as a mere approach. You can see that this is only an approach, that at each step what are the possibilities we have. We can start the previous sequence or we can start the sequence from the current position. So I have made a vector. Now what this vector will be doing, see, now if I minus k is greater or equal to 0, this means that this is having enough length to continue the previous sequence. Then what are the choices do we have? We have two choices. Either we can start the sequence from here. So if we start the sequence from here, what will be the sum of energies that will we get? Currently energy I only, because we have only this energy. And if we continue the previous sequence, then what we can do, dpi minus k plus energy of current index. And if it does not have that much previous indexes to continue, then it can directly get the energy of current state, because then it has only one option to start this from the current position. Now since we have to get the maximum one, so we can take the maximum of those from the. Now another thing comes. Now you would be thinking that okay, now we have got at each position we have got the maximum, so I am declaring a minimum, a global minimum variable, and I will take the maximum of all dp's. So uns equals to max of uns comma dpi, and now then I will be returning this answer. Now when you submit this, see what are you getting. You are getting a wrong answer. What is the reason for this wrong answer? The reason for this wrong answer is that we have given that once you have started the, you will choose starting point and then teleport to k jumps until you reach end of the magician sequence, absorbing all energy during the journey. Means once you have started the sequence, then you have to go until you are not able to jump further k. This means what? You would always be, from anywhere you start, you will always be reaching to the end k elements, last k elements. Understood? I think you must have understood, because we are given that हमें जब तक चलना है, जब तक या तो वो i प्लस की पॉसिबल ही नहीं है, अब इट इज गोइंग आउट ऑफ द एरे। इसका मतलब है एंड की एलिमेंट जो हैं वही एलिमेंट्स हमें हमारे पास होने चाहिए, यानी कि हम जो मैक्स चेक करेंगे दैट विल बी फ्रॉम द एंड ऑफ द एरे। So I equals to n minus 1, I greater equal to n minus k, I think, and here will be I minus minus, and I try to submit it. It is, yes, and k element, last k elements. So yes, it is running on this test case, and then I submit it, and after submitting it I find that it is working, and beats 28. I don't think there's no, so I think you would have understood the approach of solving this question. If you have any doubt, you are free to comment, and I will reply all the comments, all the doubts. Thank you very much.